Howdy, and welcome to the 2023 State of the Technology Industry Report by Sampi North America. My name is Spencer Hawkins, and I am the chair of TC4, Recycling of Composites. I'd like to acknowledge my co-authors who contributed to this report. Before we move on, I'd like to let you know that our report focused primarily on the recycling of carbon fiber and thermoset composites, as opposed to a general overview of sustainability and recycling within the materials area. The following two slides are an executive summary that can be gone over at your leisure. I'll point out a few bullet points here. First, multiple pathways exist to recycle carbon fiber composites. Methods include solvolysis, the use of vitrimers or reprocessable materials, pyrolysis, electromagnetic fields, superheated, and pressurized water. These technologies can be affordable to implement, with startup and legacy companies working to make recycling more attractive. However, not all of these technologies are fully mature, and their adoption is not widespread within the industry. Also, there are relatively few academic labs that are dedicated to investigating and/or developing commercially viable methods for composite recycling in the United States. This has led to a delay in the innovation of these technologies and has put the onus on industry, which is beholden to cost and shareholder interest. Furthermore, there should be more crossover globally between companies, governments, and academic labs as the world becomes more connected and concerned about sustainability of recycling. Moreover, standards need to be developed both nationally and internationally from bodies such as NIST and ISO. These will help address important questions regarding the application of and the performance of recycled carbon fibers. Finally, industry perception of degraded mechanical properties of recycled carbon fibers is pervasive. Below, you can see a figure that demonstrates the opportunities of composite recycling for developing a circular economy. First, we have the material life cycle starting with manufacturing, moving into products that can then either be reused or repaired, or when introduced into the waste stream, can be mechanically recycled into recovered materials or chemically recycled into new chemicals or building blocks. Now, in terms of the types of recycling that can be done for thermoset composites, we have mechanical recycling, such as that implemented here, where the use of shredding equipment breaks down existing parts that have met end of life. This is typically done for wind turbine blades. Thermal recycling, which is employed by carbon conversions, uses pyrolytic recycling of carbon fiber reinforced polymers. Chemical recycling, used by Vartega, is primarily used for prepreg recycling via matrix dissolution. For example, the prepreg has a resin on it that isn't fully cured. The use of a solvent can dissolve this matrix, allowing for the virgin fiber to then be reused. Recyclable thermosets can also be used, such as those by Melinda. Resale and recycling of prepregs and fibers is done by a few companies. Arnhem International typically will resell fibers from Shocker. Other companies, such as Gen2 Carbon, uses pyrolysis and then takes those recycled carbon fibers, makes non-woven mats, and commingles those with non-woven recycled carbon fibers and thermoplastics to create new products. Decom by BM Longworth uses a technique called crossolysis, which employs supercritical water equipment and is able to reclaim both the fiber and the resin. Some of the drivers to using recycled carbon fiber is decarbonization and waste reduction. So the use of natural fibers, bio-based precursors, or non-petroleum-based power or fuel. Furthermore, carbon fiber recycling is still in its infancy, and unfortunately, there's no economically competitive advantage that can be gained without compromising performance or profit. I have in bold here that the needs of the industry have primarily been focused on highly consolidated multi-material structures that are both inherently strong and durable throughout their lifetime, but that need to be easily broken down at end of life for recycling. Best practices are being developed by academia, government, and industry coming together, but there isn't an all-in-one solution that has been identified or implemented. Therefore, we should look to the recycling history of other materials to guide us. Fortunately, the automotive industry seems well poised to adopt recycled carbon fiber in areas such as body panels, interior components, and cosmetic structures. But just like every industry, cost and process time are obstacles for implementation. Composites, however, are slowly making headway as sustainable products, such as battery boxes for EVs, pressure vessels for hydrogen storage, leaf strings, and liftgate systems. The following 2 bullet points are a few examples. The current estimate of carbon fiber waste from composite production currently sits at about 30%, and the annual demand for virgin carbon fiber will outpace available production capacity within the next few years. Fortunately, recycled carbon fibers may be able to bridge this gap. Some points, though, are that the supply chain security is one of the largest challenges, and consumers need to be confident in recycled carbon fiber performance, cost, and availability. Furthermore, a shift to using thermoplastics could enable internal recycling and production of feedstock for additive manufacturing using recycled carbon fibers. Thank you for your time, and I hope you enjoyed the summary of the Recycling of Composites TC4 section for the State of the Technology Industry Report for SAMPE North America. If you have further questions, please contact our Chief Technology Officer, Raj Manchanda. Thank you. Have a nice day.